Given the geometric series 9x, 3x squared, and x cubed. Question number 1. Show that Tn equals to 27 into x over 3 to exponent n. Since we were told that this is a geometric series, we know that in a geometric series, Tn is given by the formula Tn is equals to a plus a times r to n minus 1. Then a is the first term obvious, and that first term is 9x. And r, since we are told is an arithmetic, it is geometric, so we know that is t2 over t1. And then t2, that is 3x squared, t1, 9x. And then this is t2, this is t1. And then if we were to simplify, this will be 1 over 3. Yeah, 1 over 3x. Then apply to the formula Tn equals to, for a, that is 9x, r 1 over 3x to the n minus 1. Okay, then how do we make this expression the same as this one? So I think if we can use the laws of exponents. We know the laws of exponents, 18 powers of the same base. If you multiply powers of the same base, you add the exponent, this will be x squared. Then from x squared, you can also go back here. For instance, if there's 8 exponent of 2, you multiply it by 8 exponent of 1. This will give you 8 exponent of 2 plus 1, which is a to the exponent of 3. So in this case, you're going backward instead of going forward. So what happens here, all this happening here, you're going to separate this thing, 1 over 3. That's x inside, and then let me write x multiply by this one, the exponent is negative, and this one is n. So according to the laws of exponents, if we add this thing, it will return here. If we add both of these terms, if we add 1 over 3x, the exponent of n plus this one, because the law says 18 powers of the same base. Multiplying powers of the same base, you're going to add the exponents. So after adding the exponent, this will return here. Okay. Then let me try to cancel out. Sorry. Okay, fine. So now, after then, what can we do? So we have 9x, yes. And then this one, we can just okay, this one you can multiply x by 1. When you multiply fractions, you multiply denominator by denominator, numerator by numerator. In this case, it will be 1 times x, that will be x over 3. The exponent is still n. Then for this term, 1 over 3x, the negative 1. So you can also do the same thing, x over 3 to the negative 1. And the next line, how can I cancel that? Okay. Yeah. Then we have 9x. We still have that 9x. And then this is x over 3 to the n. And then here, because of the negative 1 here, we can inverse this. We can rewrite this thing as 3 over x. Then without that negative 1. No, because if we have 3 to the negative 1, you can also change this to 1 over 3. So if we have any number raised to the exponent of 1, you can also invert that. It will still, like if you have 2 over 3 to the negative 1, you can write this thing as 3 over 2. It's an inverse. Yeah. Then we simplify. Okay, let's just rewrite so that it can be clear. 3 over x. That is x over this one, x over 3 to the n. Then here when you simplify, this is 9 times 3, that is 27, x over the x here times x over 3 to the n. And then cancel left is 27, x over 3 to the n. This is our Tn. Let's see. Yes. Then for number 2, it says what? For which values of x will the series converges? The series can only converge under the condition that -1 is less than r less than +1. If r is between -1 and r, if r is between -1 and +1, then the series will converge. So let's see, if -1, then what is our value of r? 1/3x. 1/3x less than 1. And then let's multiply both everything by 3. -1 multiplied by 3. Then the middle term also multiplied by 3. We multiply everything. 1 multiplied by 3. In this case, again, -3. Then cancel, you're left with x. Then 3. Yeah. Between -3 and +3, that is when the series will converge. Okay. And calculate the sum of infinity if x equals to 2. If x equals to 2, then the series, it was 9x plus, what are those terms? 9x, 3x squared. 3x squared plus, I think that's s cubed plus, and so on and so on. Yeah, that is x. Okay, then they say if x equals to 2. So which means we rewrite this thing as 9 into 2 plus 3, 2 plus 2. Okay, 9 times 2, that is 18, plus this is 4. 4 times 3, that is 12. That is 8. Okay, and this is a new series. And then we need to calculate an r, because the sum of infinity will require us to have a and also r. Our a, we have it is obvious, that is 18, and then our r, but we know that this is a geometric series, so just T2/T1. And then term number 2, that is 12/18. And then what is 12/18? That is 2/3. Okay, plug the formula. A is 18. 1 minus, then 2/3. Then all you need to do, press your calculators. So from your calculator, the answer is 54.